Hi, Professor. My name is Bikram Chaudhary, and this is my presentation of W course paper. My title I chose was IoT Devices and Security in Edge Network Architecture. And this is the PDF of my research paper. As for the instructions on the W course paper, I had to get abstract, main body part, main body, and introduction and conclusions. So as you can see right here, this is my paper that I have. It is 20 pages. I have included so 2 pages as I asked you, said you can only include pictures in 2 pages, no more than 2 pages. So here are some of the pages, also the references here at the end. Okay, and the title was, as I said, IoT Devices and Security in Edge Network Architecture. Okay. Abstract Edge computing is a classified computing framework that allows devices such as IoT devices with networking quick process act on the data through the networks. Edge computing allows devices in remote locations to process data at the edge of the network through various devices, as well as through a local server. It can be an important factor for businesses or organizations by allowing them to use technology to improve the response times of their remote devices and to get wealthier. More timely insights from the device data is this technology can help from an individual to a multinational businesses or organizations to unlock their full potentials to efficiency and productivity. So in this research paper, my focus is more to research on local data processing and resources constraints, security challenges, evaluating more how local data processing works, what can be benefited and advantage compared to traditional cloud computing. Okay, I'm not gonna go detail into that. I've created a PowerPoint for this, so I'm gonna show you my PowerPoint and I'll go through there. Here's my PowerPoint. As I say, the title, it is IoT Devices and Security in Edge Network Architecture. Okay, the abstract is edge computing's role. So edge computing is a classified framework allowing IoT devices to quickly process and act on data at the network edge. This improves response times, provide timely insights for businesses and organizations. So this research focuses on local data processing and resource constrained security challenges, evaluating its benefit over cloud computing. Okay. Here are the top examples of IoT examples of industrial IoT devices. As you can see, it is also one of the introduction part. So the IoT explosion, so what happened, how it exploded, or it's about to explode, which is going to replace the traditional cloud computing. So the internet is expanding rapidly, as we know that as of right now, we can see the AI industry is expanding. Not just AI, is just expanding the whole internet. Technology is improving. So internet is expanding rapidly, with the connected devices expected to exceed 25 billion by 2030. It is a huge number. By 2030, 25 billion. That is going to be remarkable. And also it'll be really challenging for IT professionals, developers to have their code or devices to be fully not proved, fully proved, basically fully proved of any attacks or cyber attacks. Okay, edge computing addresses growth, so growth demanding for data access, especially in remote areas where traditional cloud systems face a limitation, such as if an individual or businesses like in a remote location Mostly traditional cloud computing will struggle to have their data as because they are in remote access, and mostly in those areas they really don't have the infrastructure to be able to run it smoothly. That's why mostly they depend on cloud, so that way they can store their data and use it later. Okay, here is a overview of what edge versus cloud computing, overcoming the limitations. There are some drawbacks of cloud computing that we mostly know. It is increased latency because of it is in a very far from the locations that is locally, so the data is being processed through cloud, which creates a latency, and we have bandwidth constraints because it has to run in a cloud. It requires pretty big data, or you call it internet data. And lastly, it faces a security risk. As we know, working in the cloud, it could be a risk of intercepting those data while moving or transforming. So traditional cloud computing, while powerful, struggles with latency, sensitive IoT applications like autonomous vehicles, and healthcare monitoring. These are some of the really two technologies or industries that can be benefited using edge computing as compared to cloud computing, because as we know, autonomous vehicles, they require instantly solutions for their if person's using, for example, if a person's going in a electric Tesla, and the Tesla has to provide their data to the cloud server and then move back again to be able to act on any uncertain changes during that. So it could be a risk factor for humans. And same thing goes for healthcare monitoring. If there is a risk of like instant, let's say, operations or surgeries to be done, but then data has to be transferred to a cloud server and then to that person's, so it could be more dangerous. So it is more like a life-threatening. And edge computing, compared to that, edge computing solutions, it is a decentralized processing. So data is more closer to the source, reduced latency, which is a huge part, and one of the best features about the edge computing. It is the data is closer and to reduce latency. Edge computing revolutionizes data processing by bringing computation closer to the data source and addressing critical limitations of centralized cloud systems. And there is another one. Critical decision making and bandwidth. Real-time decisions, like as I said, autonomous vehicles need to make instant decisions and act upon it. Autonomous vehicles and healthcare monitoring require instantaneous data processing. Even milliseconds of delay can have severe consequences. As I said, it could be a life and death risk for anybody, not just a human. It could be for animals as well. And bandwidth strains. Billions of IT devices continuously generating data can clog network, leading to higher latency and increased operational cost, especially in bandwidth constrained setting. For example, most companies and organizations, they want profit, and they will do anything to increase their profit and decrease their cost. So having a really good bandwidth with transform data it is one of the best uh, decisions that they can make by choosing bandwidth. As we know, by 2030 there will be more than 30 20 billion, I think 30 billion uh, devices running. Using all those uh, cloud computing could increase the bandwidth, and having a millisecond of late information could risk in a factor. Here's another one, and security and privacy. It is, as we know, anything newer technology comes, we always be hesitant to use it because there will be a security and privacy uh, risk factor. It is always going to be a risk factor because as technology is expanding, we know there are some good peoples and bad peoples. Good peoples uh, who will protect, and bad people will use data to benefit themselves. So having a good security that can be beneficial for humans or individual organizations or companies, that can be one of the factors to change it to edge computing. So it's security, privacy are paramount in IoT systems, especially when sensitive data is centralized cloud system increase data breaches risk during the transmission. As we know, data is moving through cloud. It can be intercepted and used for benefit of themselves, like we getting scam calls, some scam emails with some links. So that's why we shouldn't always clicking on those emails, links, or even text. Now we get. So we always have to be careful from ourselves, and also as many professionals working hard for us to keep it safer. Edge computing mitigates these risks. So edge computing slows down this risk by processing the data locally and reduce transmission needs and limiting exposures to vulnerabilities. This enhances data security and aids compliance with privacy regulations. So there is good regulations for this to be data being processed safely, and government also is acting on this as heavily because of the technology is booming right now. AI is AI is on a different level right now, as we know. Okay, similarity. Here's another one. Okay, so benefits of using edge computing. So benefits of edge computing is reduced latency. As we know, latency is one of the key factors that could pull companies or organizations to move from cloud computing to edge computing. As process data, it'll reduce latency through bringing the data to the source. Moving the data to the near source, minimizing transfer time. The less time it has to travel in the cloud, it will be less likely to be. It's less likely to take time, and also it will minimize critical informations to be transferred less. Low bandwidth, if low bandwidth users sends only critical data, so it will send critical data only that are really important, crucial to companies or individuals, elevating network load and benefiting remote areas. So it doesn't have to send a whole lot of bunch of data. It will only send the critical data, so that way it will cut down the bandwidth uses. And enhance data security, processes and stores sensitive data locally, reducing the breach risk and ensuring compliance. So yeah, as I said, as it brings down the source, it brings down the source to the data locally as it is says edge computing, reducing it will reduce the risk of getting breached or attacked by any uh, individual or hackers, ensuring everyone's data secure. Scalability, it is it is really highly one of the important is that scalability. It can be scaled later on for thousands and billions of devices efficiently. It could be really important for big companies like even Google, Amazon, not just the smaller businesses. Efficiency scales IoT networks by offloading process to the edge devices, so it will offload everything process to the edge devices as computing use cases. So here are 4 major use cases that can be implemented in this industry. So autonomous vehicles, it is, we know, as technology is moving, more people are getting autonomous vehicles or like electric vehicles. Mostly electric vehicles are autonomous vehicles, as we know we are losing out a lot of fossil fuels, and also we are producing too many carbon in the cloud, in the environment, and which causing global warming. That's why autonomous vehicles are could be one of the good part that slows down global warming. So autonomous vehicles, real-time data processing, for instance, decisions crucial for safety and navigation. As I said, making any decisions based on their sensors and cameras. If they are using cloud computing, the data has to be processed through the cloud and then back to the car, which takes time. And if during that time period of time has to make any decisions, it will be really risking factor for the person in the car. Smart cities is also one of the industry that could be benefited using edge computing. It processes local traffic surveillance, sources data for urban management, public safety. So city management would be an amazing for this. They can monitor traffic systems, surveillance using their local data, using the edge computing, as the data will be locally in that particular area. Healthcare system, it is also one of the best one of the best one that can be benefited using edge computing. Wearable devices process vitals locally and providing immediate alerts and enhancing patient safety. If anything goes wrong, it will alert the patients, and they, not just their patients, also they can do it, process the data using the edge computing, which will be locally stored, and their primary healthcare doctors can access those data and recommend what to do and what not to do. And lastly, retail businesses could benefit extremely from using edge computing. It will optimize its inventory, personalize marketing, and enhance customer experience by analyzing shopping pattern in real time. As in, for example, we can put cameras, and the cameras capturing the data can be stored locally in that using the edge computing. It is like a server, so it will store it and store the data, and it will recommend what to put in a certain section of a retail store, or what not to put, and what to uh, using the customer's buying pattern, or like it can also be programmed as uh, for like any specific holidays time season can be used. Similarly, there's the challenges of edge computing. It is one of the main reason that edge computing is not popular right now, but in the future for sure it will be one of the uh, contenders to replace traditional cloud computing. Like hardware limitations, edge computing devices have limited computational power, storage, potentially hindering performance for complex tasks. Yep, as I said, it is a pretty newer technology than what we have. Like cloud computing is really been for a while now, and it still is, and it's gonna take a really good path. So that's why edge computing has a limited power, computational power, and really limited storage, which could be a one of the major factor that company will be hesitant to use it, because what if they use so much powers and storage, which will of course bottleneck their performance if they use so many tasks at the same time. So it will definitely bottleneck their or clog their system. So it is hardware limitation one. 2, network security. Securing numerous edges and endpoints against cyber attacks requires robust protocols and comprehensive measures. Yeah, as I said, any technology or any devices can be breached, or so that's why there must be a really top-notch comprehensive measures and regulations for these technologies to be regulated by the government, and not just the government, but also like people, as it is using their data. And lastly, the cost. Deploying and maintaining ASICs can be expensive, requiring careful budgeting and analysis of benefits. As it is a new technology, it has to, if we're to replace traditional cloud computing, we'll have to spend really a lot of money to be able to fully provide to everybody. It is because it is a newer one, so it will take a time for sure, and once everything is done, it will be one to replace traditional cloud computing. But for now, these are 3: hardware limitation, network security, and cost are the challenges that causing edge computing to lose the race against traditional cloud computing. Okay. Lastly, here's the future. Okay. The future of edge computing. So the future of edge computing is promising, especially with the evidence of 5G and upcoming 6G technology. I know there are some certain countries they are already working on 7G technology, and there are some countries that already have 6G. Even in the United States, I think there are some certain places where they have 6G technology, and low latency, increased bandwidth, with real-time application in autonomous vehicles and healthcare. Yep, having the low latency and increased bandwidth will enable a lot of car companies, healthcare systems. They will benefit so much out of using the edge computing. Integration with AI and machine learning will further enhance capabilities, allowing for complex data analysis and autonomous decision making at the edge. Edge computing will drive efficiency, scalability, and enhanced user experience across industries. And this is the PowerPoint that I created, and here's a video that I created at the start of the semester. I created a small traffic light system that can be scaled and used according to the what we using the edge computing. So it is not a big project. It's just a little one that I created for demo for this project, for this research paper. As we can see,